Hey guys, Matt Rowland here. I'm a lineman at Clark Public Utilities. Been asked to talk to you guys about generating power and shipping that power straight to your house. Start with the generator. We have a small example here of a car alternator that works just the same as the big generators do. Turns, makes electricity. We take that electricity and we send it to a substation where it steps the voltage really high. Send that all across the United States, from California to Washington, from everywhere. Ultimately, it comes to this pole-mounted transformer, or later we'll show you an underground transformer. Steps it from 7,200 volts down to the 120, 240 that we use in our house for everyday goods, such as lights or computers, charge your iPad, your phone. Here we got an underground transformer. Probably seen one of these green boxes in your neighborhood. You probably sat on it at some point in your life, but I'm sure you've heard in the past we don't recommend that. It's not extremely safe to do so. To give you kind of a brief rundown on how these work, we've got overhead power lines through your neighborhood, underground wire that attaches to the overhead power lines, comes in here at 7,200 volts, goes through the back of the transformer through some coils, creates a secondary voltage, we call it, which is 120 volts and 240 volts. That goes into your house. So this comes in from the pole and goes out to another transformer. We can go for miles from transformer to transformer to transformer. Hey guys, here we have a pole-mounted transformer. Works really similar to the pad-mounted transformer we spoke about earlier. Basically, you have your power lines that run through your neighborhood. Comes through a switch, much like a light switch in your home where we can turn the power on and off. Comes out of the switch into the top of the transformer through a series of coils. 7,200 volts in, 120 volts out, just like the pad mount. Same thing, it'll power your lights, your stove, oven, heater, air conditioning, whatever you might need power for in your house. A lot of times we'll get called out to an outage where this has opened up. Basically the switch opens up and we'll hear that the transformer has exploded. Well, that's not the case. You have a fuse here that when it sees more load than it's designed to see, it opens the fuse, which in turn is a loud boom. So when you hear your transformer blow up, it's actually the fuse opening. So we've talked about the transformers. Let's talk a little bit about the wire. Here's a piece of underground wire. This is 1/0 underground cable. This is what we would use to go, like we spoke, from transformer to transformer, or from the pole to the transformer. You can see here the elbow and the wire. Here's kind of how it looks inside of that. We've got a probe that just inserts into the transformer. That would make your electrical connection. Here's some insulation wrapped around the aluminum conductor, some semicon, and then a copper concentric that we use as our neutral. Also has a red and black jacket on it that would denote that this is power line when you find it in the ground. If you find this, please don't touch it. So we talked about our underground wire. Here's some examples of our overhead wire. We've got covered and non-covered. We've got different sizes as well. This is 2/0 or 397, so number 2. The same on the other side, just non-covered. We've got triplex. This is our service wire, goes to your house. This is overhead, and here's some examples of underground. We call this million. It's a little bit bigger cable. We use that for longer distances. And then we've got some 1/0 cable that we use basically house to house.